We got to get our ouch, get our screenshot. Hey. What? What? All right, we're all good. All right, let's do some code. So now we're doing Gantt agents that can do Gantt agents that can do like AWS, advanced AWS stuff. So let's create a Mermaid JS diagram showing how a swarm of agents would configure the most complex AWS setup of all time. It's like, let's shoot for the stars. Yeah, it's pretty good, right? Let's add a Dapper layer on top of that as well for the application layer. Nice. We'll see what this looks like. Oh, I'm not sharing my screen. Sorry, guys. I'm like looking at me. I'm like, what? That's me. All right. So we got our mermaid on this side. Mermaid live. All right. Let's see what we got. Expecting service. So let's give it the error. Yeah. So what we have then is this coder agent. So what I'm trying to figure out is, like, I have this coder agent that uses this PEP8, but now we need to do let's kind of give this and say not coder swarm, coder agent. So if we're developing mini CLI applications per AWS service, we're going to need DSPy modules that are aware of the idiosyncrasies of those AWS subsystems. Create a mermaid diagram of all of the DSPy modules we're going to need to interact with the language models to generate the CLI commands. Right? Like so what I'm realizing as I'm doing this is, like, it was having trouble like duplicating code and stuff. So let's have it make a diagram. Okay, so far the diagram's not working out. Okay. Right, so we don't need invoke. We're not talking about invocation. Well, actually, we are. So let's imagine that each CLI command has its own agent swarm, period. What might that look like? That's an innovation, right? Each CLI command kicks off a swarm. So let's try it. It's not even coming close to working. So yeah, so we're getting close. So what we need to do is we need to teach it about DSPy. And what we're going to do is we're going to do that by looking up the paper. ARX, then we're going to do DSPy. I really like the assertions paper. Oh, well, yeah, let's make the assertions like do more stuff. So we can literally grab all of this. And watch the technique here. I need your help coming up with the following paper with my following paper to this one I wrote. So we're telling it that we wrote it so that it doesn't complain about theft or whatever. But shout out to Omar, Arnav, Manish, Shangyin, Christopher, Kushik, Matei, Omar. So shouting them out. All right. Now let's make it about DSPy swarms for CLI subcommands. Yeah. Like each command is its own universe. Because I mean, in reality, that's what, well, we put it that way, right? We could consider each AWS command its own universe. And by treating it with that level of complexity, we can use Hoare logic to constrain and validate what the swarm is doing. So I have not agents. Well, this is actors. Like now we're moving from actors to agents, but watch this. Hoare. Let's go here. So we had, what is it? Precondition. No, that was not it. What was it? I think it was like, I have so much stuff in here. It might have been workflow engine. Yeah, I built my own little like workflow engine. Executor, that's not it. It's in the experiments folder. I'm feeling that it's in like the done. Function calling. Oh yeah, this was interesting. So let's just throw this in here. So like we're just going through the stuff that I have. Work in progress. Self-evolving business logic. That's a good one. One-shot pipeline. No. 4-hour work week. Ouch. Business patterns for devs. No. Condition sufficient. Maybe. I don't know. Let's just mix it up. The example for the paper should be the most complex AWS Dapper integration attempted of all time. Period. What would that look like? Or logic. Oh yeah, I forgot. It's not that. So we do need to get the is actor system. So what we're going to say is where'd it go? The swarm is going to need its own calculus, right? No. No. Start the paper with a description of the most complicated AWS system imaginable. Period. Think beyond what a human could put together. The whole point is to handle tasks that are impossible at this point. Yeah. So for instance, stop. No. Let's list the 25 most complicated AWS systems to set up through the CLI. Let's start there. Let's figure out, let's get out of its mind the stuff that it's stuck on and come up with some new stuff. I know. Watch this. So then we're going to go to the Hoare logic paper. It's a new one. Let's do that. Save that one for later. Operational semantics. Nice. Let's look at this paper. Shout out to Yanuri in Nanjing. Okay. So let's just grab this. So parameterize domain logic, right? So Let's use this paper to now define the calculus complexity of each of these 25 scenarios. Okay, so it just talks about the DLP complexity, right? So what we're going to do now is we're going to go to the word logic. See who's out in the Discord. Oh, shout out to Cola. Okay. All right. So let's do this. It's cool. So I like just grabbing random like logic and calculus and just throwing it at the language model and seeing if it's able to keep up. So let's just grab all this stuff. So we've got 26. Shout out to Darius Yahui Y Nangan. Yeah, hopefully got your names right. Let's see if I can just throw this in there. Is that too much? Do we break it? Nope, we're in there. All right. So what we're going to do is watch this. We're just going to change the paper with change the so it's so weird the way that it behaves now with the change the paper to have the case study be our CLI AWS CLI agent swarm subcommand paper. Okay. Okay, so we got right. So we got a secret weapon that we created here, which was pretty interesting. I made it so that in the CLI run command, it actually provides feedback. So we have in our utils, CLI tools, this diagnosis. So watch this. We're going to say, expand this Python using the terminology of all of the papers encoded within the function names and doc strings of the functions, period. How can we extend this system that I am showing you to create Oh, so the reason why I use the voice stuff is one, my hands are starting to kind of hurt because I'm working so much, but then also that it's seeing me type doesn't go into the transcript of the video, and the transcript of the video is what we're going to translate for people that don't speak English. So even if you see me reading things off the screen and you as maybe an English speaker sing and say, hey, Sean, why are you saying that? Well, there are many people in the world that do not speak English at all or read. Well, but even say read. Like, so for instance, how many people in the world, including English speakers, do not know how to read at above a third grade level? Right? Because we can definitely say our writing is above that level. Okay. So 770 million people are illiterate, right? 21% of adults are functionally illiterate, meaning their reading skills are at or below a third grade level, right? So that means that there's a lot of people that can talk to you and they can kind of read words, but they can't actually read. So me talking and saying these things is actually helpful to them. So now let's say if we evaluate our entire conversation outside of this, what reading level do you have to be to understand everything that is within this conversation? Right? Let's figure that out. Okay. So we can say this. How many people in the world could comfortably read all of the text that's within this conversation? Okay. So out of a world of 7.9 billion people, only 240 million people can understand everything that I'm doing, read everything that I'm doing. So whereas it might seem for you guys like, hey, Sean's just, you know, doing some stuff. Okay, cool. Good point. So David telling me to stay on topic. All right, cool. Good point. I'm gonna need you to help me out with that because the tangents do get disruptive. That's why I have to go into speed run mode sometimes. Oh yeah, you also have to help me figure out how to like play music and stuff because when nobody's interacting, it's gets a little awkward. All right, so tangents back on track. Cool. And maybe we'll have tangent section. We'll save those kind of questions for later. All right, back on topic. Now let's re-implement functions where first notation within the doc strings that is not ASCII characters. Yeah, let's start off there. So what I'm trying to do is I'm trying to get it ASCII characters like most of the letters, English letters. See, so now it's doing kind of error diagnosis, but you see it's still not actually doing any new code. So here it was doing new code. Okay, it's doing some stuff. So this is where we need to make it think about like real new functionality. So let's go to create 25 descriptions of functions that could be in this utilities file. Let's think about it that way. No. See, so immediately it starts going into random stuff, right? So use excerpts from the papers to inform the function descriptions. First, quote the paper, then write the function description. Yeah. Yeah, tangents are fun. So yeah, so the thing about it is that I think also as we kind of go along, we'll figure out how to what the parameters are. So here, what we're starting to do is get into, I mean, hell, who doesn't want to apply biadduction, which computes a pair of anti-frame and frame, such as the anti-frame is the precondition required, right? So now my framework is going to have so much random superpowered stuff. Now, here's the thing. You might say, Sean, how are we going to program that? Do you even know what that means? No, I don't know what it means. I don't care what it means, but the computer knows what it means, and the computer is going to turn it into code. So create a new file that contains each one of these functions where the doc string is the description and the function body is a reference implementation of the functionality described. The code should be at the level of a FANG Amazon system architect, period. And the code should be usable and testable. Right? Let's set the bar kind of high. The interesting thing is I don't know if like YouTube has so what's interesting about this is right now, this is all being written as functions. There's no language model being involved. Let's make it so that we now go to the DSPy assertions paper. And so now let's convert each one of these functions into its own Python module following the patterns of the DSPy assertions paper. Control flow should be managed through the language model. You know what I need? I need the community members here's something I used to do. Oh, so actually, wait, stop. It's not doing what I want. So start off. So I wanted to describe to me what that even means. Oh, actually, I realized that here's what you can do, like to have somebody show if they understand you or not. Instead of it just going back, I say, read back to me in your own words what you think I mean. Oh yeah, and then we want the why and how, and you can see, because I really wanted to think about this. We're now leaving atmosphere. We're heading into orbit. Oh yeah, David, I don't think you saw what I did for the screenshot. So I had the hat, I had the glasses, and then I had my golden 1,000-arm Buddha, and we were like, what? That kind of stuff. It's like my prop game is off the charts. So people, I think another one's going to be, I'm going to have the certificate of congressional recognition, and in the reflection, or let's see how I would get my face in there. What? It'd be like, it's the same thing. It's like, what? Or like, what is it like? How do people do it? It's like, Anyway, it's going to be off the charts. So, yeah. Okay. So, cool. So yeah, in function to verify purity is pure, right? So now we can do this. So, okay. So this is a good start. We're going to say, this is a good start, but it does not actually use the language model to do the work. I want you to analyze the DSPy paper to reverse engineer how we can get the language model to do the work instead of the method that you are using. And actually what we can do is we'll give it a hint. We'll go to our GPT for the DSPy signatures. And we'll say, can you create a DSPy signature for this module to use? So we're going to create the signature, which will make it easier. Okay, see, so now we have a signature, and then this, I believe, knows how to use signatures. Okay, so here, yeah, see how it's using chain of thought, diagnose error? It has two forward functions, right? This one's incorrect, whereas this is what's correct. So see here, I was able to get the correct code. So we can say this is the correct pattern. So what we're going to do is we're going to delete this def forward, which is hard coded basically, right? And now what we have is a DSPy module that verifies the function purity signature, right? And we can diagnose the error. It's using a chain of thought, right? It's error message, error message. That's not how it works. It's we'll do function here, and then in here, error message. So that's diagnose error message. So here, oh, you know what? It's not. This is still not correct, right? So this is still not correct. I want you to analyze what would actually make this a correct DSPy module. It's a better way to look at it, right? Like, do you know what wrong looks like? Because that's another question is, does it know what the wrong things looks like, right? Okay. So for instance, we need to stop. So it's obviously not, it's not getting it, right? So we need verify function purity, right? Let's go take the well, yeah, see, so we're initial state, we're copying the OS environment, we're running the function, and then we're seeing if the environment equals the initial state. Oh, well, actually, that makes sense. But we're not analyzing the source code. So this is good for execution. So actually, we'll put it this way. This is good for executing the function, but I want to actually take the source code of the function, provide it to the language model, and have the language model determine whether or not the function is pure, right? For security purposes, we could not execute this code, right? Yep. So one of the tips is, oh yeah, I'll move it over so it'll make it easier. One of the tips I always recommend is if you want the language model to think more the way that you're thinking, tell it that it's for security, tell it so that it's, these kinds of things that, so yeah, so language model check purity, right? Analyze language model check quirk. So here it's right, like it's still not getting it. right? So what we need to do is now we will turn it into a DSPy gen module to show it what we're talking about. So what we're doing is we're using this to like help us get the shape or the idea of what's going on, and now we need to like actually make it happen. Does this make sense, David? Like, let me know if there's anything that I might be saying that you think about it from the perspective of a 14-year-old kid who wants to learn DSPy, came across my channel and is listening to me talk. If there's something that I say where it's like, oh man, I don't know what this Sean guy is saying, that would be something to good to kind of go over. Because I think what we want to do is these first videos, right? Like the other way that I think about it is like, what is my channel going to be like when I have 1,000 videos, right? Well, the only people that are going to be checking these videos are the people that want to know what it was like in the beginning. So it might as well be top heavy on the explanations and stuff. So that's kind of with the digressions and the tangents. I might as well be heavy on the descriptions of things, because in reality, the only people that are going to watch these videos once I have 1,000 videos are the people that are going to want to really know what the deal is. So that's the other way I kind of think about it. That's why, for instance, I did 450 videos on Loom before I even started doing YouTube, because I knew if I had started doing YouTube immediately, the results would be different. So anyway, now we're back to the subject at hand. All right, DSPy gen, let's roll. Cool. So what we can do is we can now go to what here we have. So in terms of DSPy gen, we can open this up. We can move this over. And so what we can do is do DSPy PyGen. Then it's module new. Yeah, DSPy module new. Then it's class name, verify function purity, right? Then the output, or the input, we'll start with the input, is func source code. And the outputs, I think you can only do one output. Yeah, so the thing about it is I only have it so you can do one output. So we're just going to do is pure for this one, is pure. And you'll see that it's because of the way that I'm grabbing things. Well, we can add the error message. That'll be cool to see what that works. All right, so let's generate our module. Perfect. Okay, so let's see where that is, what we got, all that kind of stuff. So we go blah, 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 modules. There we go. Verify function purity module. So we're getting rid of the pipe. I really need to clean that out. Okay, we're not gonna do this. So the thing about this API call and the CLI stuff is it's really good for the system itself, but it confuses the language model. So we take it out. We can always put it back in. We can always generate the class again. That easy, right? So what we can do is now we take this signature and we do this with it. And we can do DSPy dot. And DSPy dot. All right, cool. Now we have our function, but here, if you see, we're turning the output into the is pure. So all we have to do is we say output output, because the thing about it is we could just make the output this, but then what happens is when we're doing the function purity function call, we're going to change this because in reality, we want it to just return a Boolean. Right now it returns a whatever, but we want it to do a bool. So how do we do that, right? So let's, so what we can say is, give me a impure function to test with, right? Start there. Perfect. Very impure. Plenty of side effects. Great. So what we do is we'll take this and we'll say test code equals, and there we go. So let's close this up. Oh, we can actually just do this. Equals test code. Okay, so what we can do now that we have this, we're running init DSPy, which means that we're using GPT 3.5, which should be good enough. But we'll make it Olama just because, I think most people that are actually watching this are using local models. So I might as well do that. Okay, so we're verifying the function purity. We're just seeing what the output is. So it's not going to be a Boolean, but you'll see that Python does not enforce that. So what we can do is we can then drop this instead, and we can do this. And so let's just see what we get. We'll print the result. Okay. So is pure, false, right? So what we can do then is we can say, is pure, false, right? So we have the error message. We can actually, and this is one of those kind of hacks, not hacks, but you can put it above it and it'll be the first thing that gets predicted. So let's see if that has an impact on the result. See? Immediately we got the result. So you notice how there's just intuition about this stuff. So now we have false. So how do we check now to see if this is false? So we're going to have this call. So what we're going to say is we're going to assume so we got is false. So what we're going to do is we're going to say is pure equals. So we're going to say if that actually dot is pure, right? Pure. And we're going to say if is pure dot lower. We're going to say it's going to be a string because it only returns strings. So dot lower, right? We want to get it lowercase equals false. Then return. Or we could just actually do this. Return. Super simple. So now when we run it, oh, not equal to false. And so what we can do is we'll have to check. So let's assume now. Let's give it a function. So what we can do is for this, we can do we can say assert result equal to false. Yeah, false. I think it is. It's the right thing. That it'll probably show us. Huh. Result not true. don't know how to do this. Okay. Okay, yeah, it is. So we want to assume the result is false. So then we're going to go to cursor, which has the better code generation. I mean, better code. So we're going to open up the gen. And we're in the module verify purity function. Okay. So then we're going to say now, it's so annoying. All right, just install and leave me the fuck alone. Excuse my language. No, don't show again. Stop. All right. So we're going to say K, and we're going to do, oops, that's not how you do it. Create a pure function and assert that the result is true. All right, we'll accept it. So then what you do is we do this. And so what you're seeing is this is how I create test code, right? So then we do this. And so we say, in this case, pure function code, right? So then we can just, and I'll go back here. I like running the tests in here better. We move it here, and then we can just comment it out, right? And then now you can run it. And that means that it worked. And we can validate that by going back to here. True. See? So now we have a language model verify function purity call. We now have a function. Now, keep in mind, does this specify a language? I'm not sure. Let's see how that works. So now, create a impure function call for Elixir. Okay. So now we have this Elixir code. So we can do 2 P dot. And we run this. Is pure, false. See, so now I have for any programming language that the language model understands a function that validates purity. Now we have a new model from Olama that we got, Quen from Alibaba. So we're going to check to see how that behaves. Because right now we're using phi instruct. So if we want to change the model, we just do model Quen B instruct. Let's see how the model from overseas does. Looks good so far. And then we can try this one. Okay. So here we got it. It got chatty on us. And so what do I mean by that? It means that it started talking about a lot of stuff. So it first said true, but then it said error message is pure false, right? So now we got a weird situation to deal with where it's like, what we don't know how the Quen model behaves. So it worked on the false case, but let's just see what's going on in the output. Okay, so we got self.output. Okay, so when we look at it, we got the error message. So is pure true. Oh, it then started making another function. It's very strange. So let's do this. Reasoning. So this is another trick that I do, where I do DSPy output field desk equals it's not how you spell explanation. Choice of response. Let's see if this fixes it. Okay. Perfect. You see how it fixed it? Now it gets very chatty in the reasoning. Then it just keeps doing this stuff. So it's interesting how these new models. Now I think chain of thought gets a better response. We'll just do that real quick. It's slower though. It does more thinking. I think it adds the reason. It adds a reasoning step for sure. So we'll just see if it's a cleaner instructions. Is pure annotations. So, sorry, we can add a watch. It's this, sorry. Okay, go to output. And then we can do add to watches. All right. Completions. So it adds rationale. Is pure reasoning, error message. So yeah, it's doing what I was doing. And actually, this is where I got it from, right? It adds the rationale first, then the error message is the pure. So then we can get rid of our reasoning step. And we'll just use the chain of thought. Okay, so then we look at it again. Error message none, true, perfect. And so we'll run it. And now we can run it through all of them. We'll just run it through all of them. And what we'll do is we will just print self.output. Print string representation of self. We'll run it. No. All right. Well, thank you, Quinn. And so what we can say is, now that I realize, is we can say, well, actually what we'll do this, we'll do response or true or false only. Let's see if that fixes it. Okay, we got 1, 2, 3. Perfect. So what do we have now? Something that validates the function purity, which is not a small thing, right? So one of the things is, imagine that you're trying to find a side effect in your source code and it's really tough, but you want to figure out what's going on. Well, now if you had a thing, which there is multiple, you could check to see, is it pure or not, right? And so then now now that we have this, right, we can go back to our conversation, right? Remember how I was trying to have this conversation with this? So then now what we can do is say, let's see, infer function specifications. That sounds really interesting. So let's try. Now, following this pattern exactly, create the infer function specifications module. There we go. Right? Now we have the exact. So inferring what the function, now what's interesting is we can take this all kinds of different directions. So we'll just say module new, Python infer function module. Keep in mind, this can be used in all kinds of ways, right? So we'll just first, we'll run this and see what it comes up with. Okay, so specifications. It's pretty good, right? Function takes floats, returns side effects, none. Perfect. So now let's just change this a little bit, though. I'll show you what I could do is infer types, outputs. And so then what we can say is, for everybody that's watching here, you probably know about user stories. If you have production experience, I don't know if David, you've come across user stories yet. I don't know if you know who is putting that much effort into project planning. All right. So what we can say is create a user stories output field. And actually, let's make it machine readable. And actually, let's make it machine readable YAML. Perfect. Describe the schema. Okay, that's not what we wanted. It's gone crazy. Well, actually, this can be the prefix. So watch this. I'll show you what I mean by that. So what we can do is there is a prefix. And what we can do is this, basically saying that the prefix of the user story output will be this schema string. So we'll see if that actually, what output that has. So we get our specifications. It's inferring our specifications, right? And so what we can say is, like, for instance, this is another thing that we can do. Perfect example. So now let's just say we can now have infer user story call. I don't know why this would be a dict string. Infer specifications. Dict is not, it is a string. Okay, so what we can do now is here we have the inferred specifications, but we're also returning the user story, so we can just instead grab the user story, right? Make this a string. Okay. And so instead, we can just make it, swap it out. Or actually, what we can do is we'll just go back to this. And we'll just say, create the user story version of the above. Strange that it's taking this long. No. Oh, well, good enough. Whatever. Oh, wait. Huh? Why does it generate user story? Why did it create like a wrapper for it for no reason? What we can do is just delete this. Interesting. I wonder what that timeout's about. There, it's just generating a lot of stuff. Oh, yeah. See, so here it is following that schema, just like I mentioned. Schema, title, description, title, description. Okay. So it didn't follow it exactly, but let's just do this. Well, now that we're kind of getting an understanding of how it thinks, let's do this. What we'll do is dedent. What we'll do is we'll just use this part because we don't want to influence its decision because that's what happens sometimes. Perfect. Cool. Now we got that. Oh, and now that we're doing this, let's type this out. We'll leave it there, but we'll just not show it. So it looks like it's having a little trouble getting its story straight. But what we can do is, help it out even further. Right? It's like I'm looking at what is it, kind of like what is it looking for? It's like what is it? How does it see this being done? Oh, and see, I had this triple backtick that I didn't notice. So sometimes it has the line breaks, and we'll just do it in all caps. Or we'll just do so interestingly. So the thing is, it's duplicating at some points. It's duplicating what's going on. So it's just very interesting that it has different ways of addressing these things. So now let's go to predict just to see what the difference in without the reasoning, what it looks like. All right. So we got a client partner meeting, something or other, coming up at 5:30. So we want to do some AWS stuff. So now that we're closer to this, we got this working. Not 100%, but we can work with it. Oh, what we can do is we have a function to get rid of the triple backticks. So what we can do is if we look at, it's like extract. Oh, it's in the other project. The problem with working in two different places, that's all right. Oh, actually, we got it side by side. So there it goes. All right. So markdown tools. Yeah. So we're going to move this into this proper. Extract triple backticks. This. And so, for instance, I can add a piece that says convert into working YAML, right? So we can just add another phase that says, oh, you made a mistake? Not a problem. Fix the YAML. I've done that before. So that's the thing is, as we add these modules, we're just adding capabilities that it's like, try to do this any other way. I'd like to see you try to do this with LangChain, right? And you're going to see, I'm going to just keep getting faster and faster because I'm assembling these things. So we just do this port user story, right? And just got a list instead. Join, return, list of strings. That's not true. It's a we're returning a string. And see, this is why I don't like this kind of the reason why I don't like those kinds of arguments is it's like it's not correct. And so now I have to change it in two places. So if I have to change it in two places, I'd rather just change it in one. So I have to delete the comments. Now, if the comments were super instructive and required to understand what was going on, well, then you should probably decompose your functions. See? Okay, so now we got just the user. Oh, and then let's also take out, well, one we can do from rich port print. So we can do that. So we can print it in colors, but then also let's get rid of the string, which is not adding value, right? We already know. So now we can run it. Okay, didn't add any color, but so we see title, acceptance criteria, side effects. Let's look at this one. Title, acceptance criteria, input types, side effects. So it's interesting. Like, okay, we got title here. We got title here. We only ran it twice. Huh. Yeah, it only ran it twice. That's odd. Okay, so let's go back to this. And so then now let's say, why is this not hiding? Turn hiding on. Perfect. Okay, so what we're going to say is, now I need a module that creates massively complex AWS CLI command chains to set up the most advanced AWS Dapper system of all time. All right. Create AWS commands module. Okay, so what do we got? Command chain instead of the most advanced Dapper system. And system. This isn't working here. In the system architects. So now what we're going to do is well, first let's just run it and see what happens. So, and we're just going to take Dapper out just so that it sets up any AWS system. So let's watch. Timeout. So the thing is, this model can create like 128 characters. So timeout, let's make it 30 seconds. Let's make sure that that's max tokens. Let's make sure that timeout, class timeout. So we go to Olama, local, timeout, seconds. Yeah, okay, so I don't know why it's 10, but whatever. Max tokens 150, this is good to know. Number context, don't know what that is. It's interesting. Temperature, 0. Okay. Default's llama 2. It's good to know, right? All right. So kill that. Kill that. Now we know. Okay. So let's. Oh, it tried to execute all of this shit. Excuse my language. Okay. So what we can do is, instead of printing it this way, we have, because it's very obviously doing Markdown. So instead of printing out this, printing that out, we're going to do, instead of print, we're going to go to, and we're not going to execute the commands. Let's look up, we have, we're doing our CLI tools, chatbot. Oh yeah, this is interesting. I have chatbots, by the way, like out of the box CLI chatbots in DSPy Gen. Trust me, you guys go in there, you're going to find all kinds of Christmas presents or Hanukkah or all the other ones. Sorry, non-denominational people, you'll just get presents. All right. So let's see. Maybe it's in the CLI tools. Okay, yeah. See, so we have Markdown print, right? So rich Markdown print. So we have in our Markdown tools, we'll just create one called def print, two spaces. We'll just go to cursor. All right, so when we're in cursor, and we'll switch back to DSPy fun. Oh, well, no, actually, let's stay in DSPy Gen. We were just looking at fun, so we'll stay in Gen. So we'll go to Markdown tools. Yeah, we'll move it out of fun back into Gen because Gen is the main project. Tools, utils, tools. Okay, so create a function called print markdown that uses the rich library to turn the argument string into markdown and print it. Do it now. Okay. Cool. Print markdown. I guess we're working out of DSPy Gen. So we'll say print markdown command chain. That is not how you code. That is not how you. So when I'm doing stuff like this in the main function, I always like to print import just to make sure there's no circular references or anything like that. Saves you a little bit of trouble. Okay. So no pretty colors, but so then let's take if we do our extract code on the markdown. So watch this. We do CMDS equals extract, and we can actually go to here. I'm gonna have to learn the name of I think I'm gonna have to change it to like extract code block or something that it's way too many characters. So watch this. So then we print CMDS. Okay. Oh, okay. So that we still printed this print markdown. So that's why I got confused. I'm like, huh? That's, did I break something? No. Oh, I did the wrong thing. Yeah. So looks good. I'm about to take a break before my next meeting, but we're getting pretty far. So talk to you guys later.